Hello everyone, welcome to this channel. This time I would like to offer you another series of videos. This time I have prepared a series of questions and answers based on the course of Computational Finance. The series consists of 30 questions for which I will provide you with detailed answers. The questions here in this course, in these materials, you can consider as a good exam questions, but also potentially interview questions if you are interested in a quant type of job. All the materials, so the slides covered in this series, and also materials like lectures, everything you will find in the links provided in the description of these videos. So let's take a look what is this series about. First, I would like to show you this is the playlist of all the lectures that are used for this series of questions and answers. So every time, every release of the video, there will be a question for which I will provide you with slides with an answer to that question. And of course, if you are interested to dive deeper in those materials, I also provide you links to in which lecture you will find some more materials if you like to dive into that particular question. So in the series of computational finance lectures, there are 14 lectures. Starting with stocks and stochastics, there is a lot of attention about the pricing of options, implied volatilities, jumps, affine diffusion models, stochastic volatility, and pricing of some exotic derivatives. So if you are interested in these lectures, those are available in a playlist in this channel. So let's take a look at the questions I have prepared in this series. So from every lecture, I have taken about 2 or 3 or sometimes 4 questions which I found particularly interesting. And for each of them, I will provide you with an answer. Sometimes those answers take 2 minutes. Sometimes it's a bit more extensive, where it will take about maybe 10 or even 15 minutes, depending on the complexity of the question. Okay, so we start in the first lecture. We start simply. Of course, it's a very beginning of the course. So here, the first question is, can we use the same pricing model for different asset classes? So a little bit of global question, whether you are familiar with different models in different asset classes, what are the differences between them, how they vary, and so on. The second question is about the money savings account and the relation to zero coupon bond. So a little bit also interesting question, whether you understand the concept of stochastic interest rates, and what is how the money savings account is related to interest rate products. Then we go to lecture number 2, where we focus here on implied volatility. So this is question number 3, and then pricing of options using arithmetic Brownian motions. And then another question is about a question with what's the difference between the stochastic process and random variable. So this is also a little bit of catching up, whether you know the details about the stochastic processes. And the final question is a comparison of arithmetic Brownian motion and geometric Brownian motion for modeling of stock process. Lecture number 3 is about the Feynman-Katz. So this is question number 8 with a Feynman-Katz formula and what type of sanity checks you can perform in order to make sure, or you can check what kind of sanity checks you can do to check whether simulated stock makes sense. So sometimes we simulate stochastic differential equations. And how would you know whether the simulated stock it's correct? Maybe not fully correct, but what kind of obvious mistakes you can do. So in here, it's a question about whether you have experience in coding of stock processes, discretization of stochastic differential equations, and whether you have some intuition where to look at if you have a simulation, where to look whether the results are completely bad, or potentially they are maybe very good. So this question is about. Question 9 and 10, those are from lecture number 4. This is about the implied volatility term structure and deficiencies of the Black-Scholes model. So this is a little bit more so related to the previous lectures, whether you understand the concept of Black-Scholes model, what are the limitations, and how potentially you could solve those limitations, how you can expand those. So this question is about that. Here we have another 10 questions, lecture number 5. Here this lecture number 5 is about jump processes. So the first question is about the ethos table and the relation to Poisson process. So if you have a stochastic differential equation in which we have a Poisson process, how this Ito table looks like. Next point is about implied volatility and jumps. So what happens to stochastic differential equation and implied volatility, corresponding implied volatility, if you add jumps to that model? Question number 13 is about characteristic function for models with jumps. So how to derive it. And here there will be a little bit, this question is a bit, maybe sometimes a little bit technical. So you can answer it in a very global way, but also you can go dive into details. And this is one of those questions where I will provide you with step-by-step derivations and the key elements of the derivations of that characteristic function. Lecture number 6 was about stochastic volatility models. So here the first question is about the Heston model and time-dependent parameters, whether the model defined such is affine or not. And what, of course, what are the affinity conditions and so on. So this is a very interesting question. Question number 15 is whether the adding more factors in your stochastic model, whether it will help you obtaining better results. In which scenario you can think of adding more factors and when it is not a good idea. So this is also about this question is about your knowledge about the models and also your experience in terms of making models more complicated, more complex. Sometimes it's not of added value if you add more factors. Adding more factors, however, it can be very important to add. So you need to understand what are the nuances if you are a financial engineer once you model particular asset class. Lecture number 7, those are questions number 16 and 17. Interpretation of the Heston model, its parameters and impact on implied volatility. And question number 17 is about modeling of volatility using of arithmetic Brownian motion. So what are the consequences if you model volatility using normal process, so process for which we could have a positive and also negative realizations. Lecture number 8 is about Fourier transformations. So here it is a challenging question. Why would you use Fourier transformation? Why don't you use pricing using brute force integration? So it's also about your knowledge of understanding why you actually apply this type of method for pricing, why you just don't do something more straightforward. And this is this question about. And then question number 8 is also a practical question where we have to answer what happens if you don't obtain convergence in your pricing. So suppose you have implemented some Fourier techniques for pricing of derivatives. However, you don't get convergence. This means you increase number of expansion terms. However, the results are not getting better. How to do that? How to fix that type of problem? So this is again question. It's about more hands-on exercise. If you have encountered this kind of problem, what would you do to fix that? Lecture number 9 is about Monte Carlo. So the first question is about what is the standard error, how to interpret it, and what is actually the point of looking at this error. Sometimes if you simulate a process, just look at the price. But how to measure whether the price you're seeing is not going to change dramatically if you, for example, change number of Monte Carlo paths by a little bit. So this is this type of question here. Question number 21 is again about Monte Carlo. Here is about a weak and strong convergence. So how to distinguish between those two types of convergence in the context of Monte Carlo pricing. Then we have lecture number 10. This is again about Monte Carlo. So the first part is about challenges when you're dealing with a CIR type of process. So it's a Cox-Ingersoll-Ross type of process in a context of pricing or simulation using Euler discretization technique. And the question number 23 is about Monte Carlo against Fourier transformation. So in which scenarios you would apply Monte Carlo, in which scenario you would say Fourier transformation is essential to have formal pricing. This is again a question about your understanding about the concept of pricing, calibration, and simulation of some exotic derivatives. So you see, it's not always about knowing a method. It's also very important to understand in which scenario, in which method you would apply for particular type of problem. So this is the key element that I try to teach you in this series of lectures. Question number 24 and 25 is about also simulation. So first one is about jumps, how to hedge jumps in a process. And the next one is about sensitivities. So it's also related to hedging. So pathwise sensitivity here in particular. So what is pathwise sensitivity, how to calculate that, and what are the benefits of using this, let's say, more advanced techniques for calculating of sensitivities. Lecture number 12. So here we have 3 questions. First about the Bayes model. What is it, and how we can use it for pricing? What are the benefits of using this particular model? Next, we have a question about the relation of European options and forward start options. So this is a question about your understanding of pricing of some more involved, more complex derivatives than simple plain vanilla. Then question number 12 is about the calibration, how to choose model, how would you approach a problem of calibration, what instruments would you choose if you have a calibration problem, and how this relates the choice of your instruments to the derivative that you want to price. So this is kind of also a question consisting of multiple steps that will determine whether you understand the whole process of pricing of financial derivatives. And then lecture number 13 is about the calibration, how to choose objective function. So in calibration you may have multiple objective functions, and here we discuss potential choices. What are the benefits, and sometimes what are the limitations? What are the costs, especially in terms of computational costs, if you choose particular objective function. And the final question of the series, so question number 30, is about also again about knowing derivatives. Here it is about chooser options. So the series is made out of those 30 questions. Each video I will post a question and I will provide you with answer with some slides. So I have prepared around 100 slides for all these 30 questions. If you find that my answer is maybe not detailed enough, then you will find a link to a particular lecture where you can revisit the lecture and learn those materials yourself. So I think this series of 30 questions is quite broad, and also it's a first volume. So as you can see, here's first volume. If you like this volume, afterwards I can prepare a next volume where we will further expand our knowledge in computational finance. So I hope you enjoyed the series, and see you next time. Bye bye.